Good morning, this is your Math Sensei, Mr. Spensei, and this is notes on Unit 3, Day 1, Parallel Lines. Okay, so first off, warm up. Give the equation y equals negative 3x plus 2. Give the y-intercept, where our y-intercept in this case is just going to be 0, 2, because this is b, because this is y equals mx plus b. So our intercept is at 0, 2, where this is the x and this is the y. And our slope as a fraction is negative 3 over 1 because m is our slope. So we're going to go plot 0, 2 right here. And then please remember the angry man eyebrows. It's negative, so we're going down. And reversing. And if we connect our points, we should have a straight line if I did everything correctly. Okay, the next thing, given the equation y minus 8 equals negative 3 parenthesis x plus 6, solve for y and graph it on the left. Before we do that, let's identify our starting point. Please remember what they've given us here is y minus 8 equals negative 3 parenthesis x plus 6. And that's in y minus y1 equals m times x minus x1. So our starting point, we know it's going to be an x and this is going to be a y. So we definitely have a 6 and an 8. But because we have a negative here, we have to swap the sign. So essentially it's a liar. So this negative 8 becomes a positive 8. And this positive 6 becomes a negative 6. So that's our starting point. And I'm going to go ahead and plot that at negative 6, positive 8. So that's up here at the very top, negative 6 and positive 8. And our slope is here at m, which is again negative 3 over 1. So 1, 2, 3 over and 1, 1, 2, 3 over and 1. And if you notice, when we draw this, the second line, it's parallel to the first. And the reason it's parallel is because these slopes are the same. Both of them had a negative 3 as their slope. They all both had the same slope. If you have the same slope and different y-intercepts, then you have parallel lines. Now, it asked us to solve for y and graph. Okay, well, we've already graphed it, but I'm going to solve for y. And the reason we solve for y is just so that we could put it into Desmos if we need to see it. So, because Desmos will not graph it if it's like this. But if I add 8 to both sides, then I get y equals negative 3 parenthesis x plus 6 plus 8. So what I'm going to do is I'm going to graph, since this one's already in y equals, and now we have this in y equals, I'm going to put those back into Desmos just so you can see how it would look. So we're going to go ahead and share. So we'll do the first one first. We'll do the one that's in slope-intercept form. So y equals negative 3x plus 2. And that was our first line, and that looks just like it. It has our y-intercept at 2, etc. And so, and if we wanted to see a table of values, we could hit, and there we have a table of values for it. I'm going to go ahead and close that table up. And we're going to go ahead and enter our next line, which we put into, we move the 8, and we have y equals negative 3 parentheses x plus 6. And then we had a minus plus 8. And we ended up with this blue line, and you can see right there we ended up with two parallel lines, and we zoom out. It's like, oh, they never ever cross. Okay. All right. So that's all we wanted to see with that. The next thing says, given the equation 6x plus 2y equals negative 10, solve for y and graph it on the left. So once again, we need to solve for y. So I'm going to write the equation down, 6x plus 2y equals negative 10. So to do that, this is a positive 6x. So I need to do the opposite of that, which is make a subtraction. So now I have 2y equals negative 6x plus 10. These are not like terms. They cannot be combined. We cannot combine the x's with a constant. I need to separate this 2y, so I'm going to do that by division. And I get y equals negative 3x plus 5. Well, this is in y slope-intercept form, y equals mx plus b. So we know that our y-intercept is at 5. So I'm going to go ahead and mark positive 5 on the graph. Oh, excuse me for just a moment. There's an error here. That should have been a negative 10. So this is a negative 10 divided by 2 gives me negative 5. So this should have been a negative 5. So now I'm going to mark negative 5 on the graph. My slope, so m equals negative 3 over 1. B was negative 5. So negative 3 over 1. So down 1, 2, 3, and over 1. Somehow or another, I did something incorrectly. No, I did not. Okay, negative 3 over 1. Oop, that's that point right there. Then 1, 2, 3 over 1, 1, 2, 3 over 1, and 1, 2, 3 over 1, and 1, 2, 3 over 1. I thought I'd made a mistake, but I had not. And so we still get another parallel line. But once again, it's really important to solve for y. If you solve for y, once you have it in y equals form, like these, then you can go ahead and put it into Desmos. All right, let's look at the next one. So we have parallel lines. So what do we notice about those parallel lines? Well, all of them have exactly the same slope. So parallel lines are lines that have the same slope, but different y-intercept. So same slope, different y-intercepts. So without even graphing these, take a look at these and go, hey, are these parallel lines? Justify your response. Well, I look at it and I go, well, you know what? This is a slope of negative 3 over 1. This has a slope over negative 3 over 1. And this has a slope of negative 3 over 1. So far we're looking good. They have all the same slopes. And remember, this is just because it's y equals mx plus b. In my ordered pair, 0, 2. This is tricky. There's nothing there, so that means it's 0, 0. So this has a different y-intercept. And then this is 0, negative 4. So all of them have the same slope. They all have different y-intercepts. So they are, in fact, parallel lines. So next thing it says is graph them. So I'm going to go to 0, 2 and plot a point. And 1, 2, 3 over 1, 1, 2, 3. Remember, it's a negative slope, so we're going to be going down. And then we have the next one is negative 3, 0, 0. We're starting at 0, 0. We start at the y-intercept. And 1, 2, 3. And these lines are really close together. And then the last one is at 0, -4. The same slope of 1, 2, 3, and over 1. And there we go. All right, moving on to the next. So find the point slope form of the equation parallel to y equals 5/3 x minus 4. So we want it parallel. We want to find the point slope. So it means we're going to use the y minus y1 equals m times x minus x1 and passes through the point this. All right. So we need it to look like, well, and it says graph both equations. Let's go ahead and graph this first one, y equals 5/3 x minus 4. We're going to start off with the y-intercept, which is at -4. And it's a +5, so up 1, 2, 3, oops, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3. All right. So they want us to write a new one using this formula. So I'm going to write it down. So y minus y1 equals m times x minus x1. Well, we know the slope has to be the same to be parallel. So this is 5/3. This is x, this is y. The y value is 5. The x value is 6. But remember, when they go into the equation, they become liars and they switch signs because of this negative, and negative is the change agent. So this -5 becomes a +5, and this -6 becomes a +6. Okay, this is still my starting point. Even though they're liars here, that's still my starting point. So I have to go to -6, -5, which is about there. And I need to count out my slope of 5/3. 1, 2, 3, 4, 5 over 3. 1, 2, 3, 4, 5, and over 1, 2, 3. And we end up with two parallel lines. Continuing on to the last one. Find the point slope form of the equation parallel to y plus 7 equals -2, parenthesis x minus 8, that passes through the point -5, 4. All right, so we have a couple things again. We have point slope form, and it wants us to, and it doesn't say graph both of them, but we're going to graph both of them. So the first one, please remember, this is my y value is 7 and my x value is 8. That's what they gave me. But inside there, they're liars. So this is actually a +8 and this is a -7. So I need to go graph that point. That's my starting point. +8, -7. And that's right here. And my slope is -2/1. So we're going down because remember the angry man eyebrows. So 1, 2/1. And we're going to put a lot of these in there because they're so close together. So there they all are. And we're going to connect our points. That looks pretty good. So we need to write it in point slope form, and point slope form has the equation y minus y1 equals m times x minus x1. And remember, this is my x, this is my y. So we know we have y and 4 equals, my slope has to be the same in order to be parallel, so -2, and we have x and 5. All right, we know that this is my starting point, so let's go ahead and graph that. So at -5, +4, and this 4 is positive here, so we write it negative here because it becomes a liar because of the change agent, the negative change agent there. And this -5 becomes a +5. All right, well, we have a -2 slope. So 1, 2, and all I'm doing is counting up 2 and over 1. And once again, we end up with 2 parallel lines. Okay, please remember parallel lines, lines that have the same slope and different y-intercepts. Slopes must be the same. All right, I appreciate you watching. Hope this helped and look forward to seeing you on the next one. Thank you.